This one is figure 2.18. This one is door. It is rotating about a hinge with angle theta. We can represent its position through just angle theta. This one is a point in xy plane, x and y coordinates. This one is a coin on the table, say xy plane. The n-dimensional space containing all possible configuration of the robot is called the configuration space, C space. Here we require just theta to represent it. Here we require two numbers. One is x coordinate, this one, and the other is y coordinate. Here we require three numbers. 1 point, x coordinate, y coordinate, and for orientation, some angle theta with reference line. Figure 2.2a, choosing the 3 points fixed to the coin. Here, A, B and C. There are 3 points. Here, coin in the plane, these 3 points A, B and C. And here the coin in 3D plane, 3D space. So for figure 2.2a, now 2.2b, once the location of A is chosen, B must lie on a circle of radius DAB centered at A. For example, suppose this one is the coin and there are 3 points, say A, B and C. Suppose this one is xy plane, this one is x-axis, this one is y-axis. So we can fix point A at any arbitrary point. Then after, suppose this one is the point A at certain point on the xy plane. After that we can rotate it, keeping A fixed. But for the location of B, it must lie on the circle of radius DAB centered at A. And then after choosing for B, we require, because of it is on the circle of radius DAB and centered at A, so we require to represent it an angle theta on circular frame. After B, C must lie on the circle on the intersection of two circles of radius DAC and DBC. For this, we have two intersecting points. One is here. If we flip, keeping A and B fixed this way, C is also here. One is for head, the other is for tail. Okay. Now this one, C must lie at the intersection of the circle centered at A and B. Only one of these two intersections corresponds to heads of configuration. Now this one, the configuration of coin in 3-dimensional space is given by the 3 coordinates A, 2 angles, 3 coordinates of point A and 2 angles to the point B on the sphere of radius DAB centered at A, and 1 angle to the point C on the circle of defined by the intersection of the two spheres centered at A and the sphere centered at B. This way, suppose we want to define the position and orientation of the coin in 3D space. This one is x coordinate, so x axis, this one is y axis, and this one is z axis. Then after we can fix suppose the first point A at any point x a, y a, z a. Then after we must lie on the spherical surface of radius DAB centered at A. And for this spherical surface, we require 2 coordinates, longitude and latitude for sphere. After location of B is fixed, C must lie on the sphere, on the intersecting of two spheres, having radius DAC centered at A and having radius DBC centered at B. And for these two spheres, the intersecting side is circle. So for this, we require one more angle. So the number of degrees of freedom of a coin in 3D space, xa, ya, za, and then after for B, there are two numbers, one is longitude and the other is latitude. And then after C, for C, it is fixed because of it is on the intersecting circle of two spheres having radius DAC and DBC, centered at A and centered at B. It's a circle, and on a circle we can fix the point C by some angle theta, parametric angle theta. Now, continuing with figure 2.2, once a coordinate frame xy is attached to the plane, the position of these points in the plane are written xa by xb by b and xc by c. If the points could be placed independently, if we imagine that anywhere in the plane, the coil would have 6 degrees of freedom, 2 for each of the 3 points. So there are 6 degrees of freedom. But here DAB, DBC and DC are constant for rigid body, no matter where the coil is, but this distance remain fixed. So the following equality constraints on the coordinates xa by xb by b and xc by c must therefore always be satisfied. DAB is this fixed, xa minus it's a distant formula, DBC is this, it's a distant formula, and DAC is this fixed. So overall 6 degrees of freedom, but 3 constraints are there. So 6 minus 3. On net, the total number of degree of freedom of a coil in a plane is 3, x, y, theta. That is one point with x coordinate, y coordinate, and then after angle theta for the orientation. First, the position of point A, we may choose it be anything we want, so we have 2 degrees of freedom to specify the first point, namely xa y. Once xa y is specified, the constraints DAB, that is DAB